Hello friends, welcome. In this session, let us see how to solve a linear equation in two variables by using elimination method, in which we equate the coefficients of a particular variable which we want to eliminate, so that we can convert the linear equation in two variable into linear equation in one variable. So what are the steps we have to follow so that we can solve it by linear equation? In two variable, we can solve it by elimination method. In the last session, we have seen solving the linear equation in two variables algebraically by using substitution method, in which we have expressed one variable in terms of other variable, so that we can go to the other equation and substitute that variable value, and it becomes a linear equation in one variable, and we solved it. So in this, what we will do, the approach is, we will also convert this linear equation in two variables into one variable. Only the thing is, here we equate the coefficients of the variable which we want to eliminate first. So for that, let me take a generic example. Let us say we have a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0. Now let us say we want to eliminate a variable y. Let us say we want to eliminate the variable y. If I want to eliminate the variable y, I should have the coefficient of y equal in both the equations. For that, what I should do, what is the coefficient of y in the first equation, b1, and the second one is b2. So I have to make both b1 and b2 equal. So I should multiply the first equation and second equation with some values, so that both b1 and b2 will be equal. Now you know that if you have two numbers, their LCM is what makes both of them equal. So I will multiply the first one with b2 and the second equation with b1, so that both the equations will have coefficient of variable y which we want to eliminate equal to b1, b2. Now once we go there, what we will do after that, we will subtract them, because we have both same sign here. We subtract, that will cancel y, then you will have directly finding out the value of x. So that is the approach which we will be following. So let me show you one example. It's pretty easy. Let's consider these two equations. We have 7x plus 10y equal to 1, 5x minus 4y equal to 23. Both of them are linear equations in two variables. We can see that the power of variables is 1, and we have two equations. Okay, now the idea is to how to solve this. For that, we'll be using the elimination by equating the coefficients. First, which variable we want to eliminate? Let us say I want to eliminate the variable y. Okay, now what is the quotient of y in the first equation? 10. What is the quotient of y in the second equation? 4. So I have numbers. I am not taking signs actually, I am just taking numbers. 10 and 4, I have to find out the LCM now. Why I have to find out the LCM? Because that will tell me by which number I have to multiply these equations respectively, so that I can eliminate the variable y. Okay, 10 and 4 LCM. 10 is 2 into 5 and 4 is 2 into 2. So we know that 2 is common. LCM is 2 into 2 into 5, that's equal to 20. Now if LCM equal to 20, that means both these coefficients should be made to 20, so that you can eliminate the variable. So let us see, our next step will be, by which value I should multiply the first equation. We know that 10 into 2 is equal to 20. So I will write down 2 into 7x plus 10y is equal to 2. 2 into 1 is 2, or can I say 14x plus 20y is equal to 2. Now let's go to the second equation. Second equation, we have 4. we have to make this value 20. So by what I have to multiply? I have to multiply with 5, so that I can have 2 tens are 20, 4 fives are 20. So I have to multiply this whole equation with 5. So let me do that. I will say 5 into 5x minus 4y is equal to 5 into 23, which is nothing but equal to 5 fives are 25x, 5 into 4 is minus 20y, 5 into 23 equal to 115. Now you can see that both the equations we have variable coefficient same. Okay, now you have opposite signs, so I can add them. If it is same signs, we have to subtract. Now we will add them because 20 by 25 will cancel if I add them, and I have 14x plus 25x 39x is equal to 2 plus 115 117. That gives me x equal to 117 by 39, that is equal to 3. Now once I got the value of x, I can go to any one of the equations. I can find out the value of y by substituting. I will say 5 into 3 minus 4y is equal to 23, or can I say minus 4y equal to 23 minus 15, or can I say minus 4y is equal to 8, or y equal to minus 2. So 3 comma minus 2 is the solution for this linear system of linear equations in two variables. Let us substitute that. 7 into 3 is 21. 7 into 3 is 21 minus 2 into 10 is 20, which is equal to 1. So that's correct. 5 into x is 15 minus 4 into y. Y is minus 2. Minus into minus is plus. 15 plus 8 is 23. So that's a simple example. So let me just, before we go to the next example, let's have a look at the concept or the algorithm or the steps what we have to follow. We will be given, let me just try to simplify this a little bit so that it doesn't look like that much cluttered. Okay, right. Now suppose we have been given two equations. What we will do, first we have to think about which variable we want to eliminate. Now suppose I say I want to eliminate variable y in both of them. I can do that only when the coefficients are equal. To equate the coefficients, what I have to do is find out the LCM of those two. I have 10 and 4, LCM is 20. Now I have to decide on by which value I have to multiply. Nothing but the LCM divided by the coefficient is the value which you have to multiply. So the idea is to equate the coefficients of that variable in both the equations. Now I have 10 here, I have to multiply with 2 so that it will become LCM 20. Similarly I have 4 here, I have to multiply with 5 so that it will become LCM 20. Now you have to multiply this whole equation with 2 and this whole equation with 5. That is what we have done. Now we see that the signs are opposite, that means you can add them. If the signs are same, then you have to subtract. You simplify, you get the value of x. Once we get the value of x, we can leverage on any one of the equations we have and we will directly go there and substitute so that we can find the value of the other variable. Let us do some more examples. Let's look at this example. We have 15x plus 11y equal to 56, 4x plus 7y equal to 19. So how to solve these two linear equations in two variables to find out the value of x and y. Now we know that as part of elimination method we have to equate the coefficients of a variable, and as usual we'll go with y only. We'll go ahead with y. We want to eliminate y. So the coefficient in first equation is 11 and in the second equation it is 7, and we know LCM of 11 and 7 is equal to 11 into 7, that's equal to 77. So the first equation needs to be multiplied with 7 so that it will become 7 into 11, and similarly the second equation needs to be multiplied with 11 so that again it will become 11 into 7, 77y. So let's go ahead and do that. Okay, so we'll take the first equation and multiply that with 7. We'll write it as 7 into 15x plus 11y equal to 56. Similarly, we will take the second equation and multiply that with 11. I will have 11 into 4x plus 7y equal to 19. We'll try to simplify this so that we can eliminate the variable y. I will have 105x plus 77y equal to 7 into 56, which is 392. Similarly, I have 11 into 4 is 44x plus 11 into 7 is 77y equal to 11 into 19, that is equal to 209. Now you can see in the last example we have the sign same for the sign opposite for the variable y which we want to eliminate, whereas here it is same sign. If it is same sign, then I should do subtraction. So all the signs will change when I subtract, and if I simplify, I will cancel the variable y when I subtract. I will have 105 minus 44, that is 61x equal to 183. If I simplify, x equal to 183 by 61, that's equal to 3. So if I got x equal to 3, I can go to any one of the equations to get the value of y. I will take this one simple. So I will say 4 into 3, that is x value, plus 7y is equal to 19. Now let's try to take this 4 into 3 to other side, that is 12. I will have 7y equal to 19 minus 12, or 7y equal to 7, or that will give me y equal to 1. So we have the values 3 comma 1 which will satisfy these two equations. Let us check that. 15 into 3 45 plus 11 56, 4 into 3 12 plus 7 19. So we are good to go. So the solution is 3 comma 1. So you can actually stick to one variable and go ahead with it, or you can eliminate x also. Maybe in the next example we will try to eliminate x because we are eliminating always y. Now only one thing we have to remember is which variable we want to eliminate, that variable coefficient we have to make equal. If they are not equal as of now, like 11 and 7, how to make them equal is always by making them equal to the LCM of those two numbers. 11 and 7 LCM is 77. So the first equation has to be multiplied by 7 and the second one by 11. Let's look into one more example. Now we have taken an example where we want to eliminate x now because we are eliminating always y. Okay, let's think about eliminating x now. Also you see that y is having 7 and 23, both are prime numbers, so the LCM is nothing but product of them. That makes it very big. First equation I have to multiply with 23 and second one is 7, which is a little bit maybe complicated. So we'll try to go for x equating the coefficient of x, because I have 6 comma 9. 6 comma 9 means LCM is equal to LCM of 6 comma 9. 6 comma 9. 6 is 2 into 3. 9 is 3 into 3. So can I say 2 into 3 into 3? That's nothing but equal to 18. 18 is the number which occurs first time common in both the tables of 6 and 9. That's the definition of LCM, least common multiple. 6 3s and 9 2s. Now which number I have to multiply? The first one to make this 18. To make this 18 I have to multiply by what? 6 into 3. So I have to multiply everything with 3. Similarly here I have to make it 18. I have 9, so I have to multiply with 2. So let me write it down. We will say, we'll do it fast now because you are already aware of this method. So 3 into 6x plus 7y equal to minus 1 is the one, and the other one is 2 into 9x plus 23y equal to minus 14. If we just simplify this, we'll have 18x plus 21y equal to minus 3, and if you multiply 2 with 2, second equation will have 18x. See, 18x will cancel now. If I subtract, I will have 46y equal to minus 28. Now the coefficient signs are same in both of them, both are plus only. So what I should do obviously is I have to subtract them. So this becomes minus, the second one becomes minus, and this becomes plus when I subtract. So 8x will cancel out. I will have 21 minus 46, that is minus 25y equal to 28 minus 3, 25. So can I say y equal to minus 1? If I got y equal to minus 1, then obviously I can easily find out what is the value of x. For that I will go to this equation and say 6x plus 7 into y, that is minus 1, equal to minus 1. I can also say 6x minus 7 equal to minus 1, that is 1, which is nothing but 6x equal to 6. That gives me x equal to 1. So we have x equal to 1 and y equal to minus 1. Let's substitute that and verify. 6 into 1 is 6, 6 minus 7 is minus 1, 9 into 1 is 9 into 1 is 9, 23 into minus 1 is minus 23, 9x plus 23y is minus 14. So in this session we have seen how to solve a linear equation in two variable by using the elimination method. We understood the concept. The concept is to equate the coefficients of the variable so that you can convert the linear equation in two variable into equation in one variable. The difference between earlier method and this method is, earlier method we are expressing one variable in terms of other, and we are going to the other equation and substituting that, whereas here we are equating the coefficients. To equate the coefficients of the variable which we want to eliminate, we have to find out the LCM of them, because that is the number which we want to get for both the variables. So to do that, you have to multiply the first equation and the second equation with respect to numbers, so that both the coefficients will become equal to LCM. Then you can subtract or add them according to the signs of that variable in both the equations. Then you can find out the value of x. Once you got the, you can find out the value of x or y. Once you got the value of one variable, the other variable can be found out easily. So in the next session we will look into examples where we have equations which can be reduced to linear equation in two variables. That means by looking at them, they are not linear equations in two variables, but we can do a little bit of substitution and we can see that they can be converted into linear equation in two variables. That is what we will look into in the next session. Thanks for your time and support. Bye for now.